For trig application questions, don't fit the axis to the curve because you need to show where the level of the ground is 0. If it's a Ferris wheel question, you need to show where the time is 0, etc., etc. So you don't just start fixing the axis to the curve. You need to draw a more complete diagram. In one area of the Bay of Fundy, the tides cause the water level to rise. Oh, let's just kind of draw a sketch as we go. Rises 6 up, average sea level 6 down. So this here goes up 6. Right away, what do you know? What does 6 tell you? So A equals 6. One cycle is completed every 12 hours, so you know the period equals 12, right? Assume that changes in the depth of the water occur over time can be modeled by a sine function. We're going to find equations using sine and cosine to get you used to it. If the water is at average sea level at midnight, so let's now start. So that means this point at average sea level is at midnight. Okay, so let's just start drawing that here. I just want to get to the... Okay. Assume that low tide is at 2 meters. This is 2 meters. It goes 6 above and 6 below, so we're going to add 6. This is going to be 8 meters. It goes 6 above, 14 meters. So this is depth with respect to time, and we're using meters. So far, so good? Yes. The equilibrium line. That's the lowest. So they told us the lowest point, so we add 6, add 6. Right? So this is going to be time in hours. Right? That's going to be time in hours. Okay, they want us to draw it over the next 24 hours. So but each cycle is 12 hours, so that's really 3 cycles. So we'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so if the period is 4, special points occur every 12 divided by 4. The period is 12. Special points is period divided by 4, so it's at 3. So this is going to be 3, 6, 9, 12, 15, 18, 21, 24, 27. I guess I'm doing okay. No, I don't think I am. 3, 6, 9, 12, plus 3, plus 3, plus 3. How many cycles did they want? It's for 24. Oh, I guess it's just 2 cycles they want. I thought something was funny. Okay, water is at average sea level at midnight, so we're going to say this is midnight, and our time is in hours after midnight, right? It's measured in hours after midnight. So it's at average sea level. So then the tide's coming in, so it's going to rise up, and then it goes down, and then it goes down, then it goes back up, then it goes up, then it goes down again, there, then it starts to go up, there. So far, so good? Our equilibrium line is d of t equals 8. because that's our sea level, right? Yes.
Where do you get like the 2 meters?
They told us that low tide is a depth of 2. And we know it goes 6 up and 6 below, 6 up and 6 below, right? So add 6, add 6.
I guess like the x-axis is like the bed, like the seabed.
I guess it's the, yeah,
Okay.
yeah, I guess it's where the bottom of the lake is or whatever. Yeah.
So the y-axis is at 2 o'clock.
No, it's 0 hours past midnight.
But if it says the water's at average level at 2,
No, it says it's at average level at midnight.
yeah, but in
The low,
C,
they're just telling you when low is. But we're starting here. At midnight it's at 8, it's at the sea level. At midnight it's at sea level, right? And then the lowest point in the water is 2 meters. We need that low point, right? We need a starting point. Okay? Okay, so we're working with, they're saying sine is good. So D, we're working with y equals a sine, right? K, t minus d plus c. So in this case, our y is d of t. What's our a,
6.
right? Because this here is 6. Sine, oh, we have to calculate our k. You know our period is equal to 12, and period equals 2 pi over k. That's the formula I gave you. So 12 equals 2 pi over k. 12k equals 2 pi. K equals 2 pi over 12. K equals pi by 6. So our k is pi by 6. We just calculate it. There has been no phase shift, right? We're using a sine function. Sine usually starts at the equilibrium line, right? So there's no phase shift. So that's t, and our equilibrium line is 8. Good? What if I wanted to draw, what if I wanted to draw, what if I wanted a cosine equation? How would that be different? Yep.
It would be like 6 cos pi by 3. Um,
Why is it pi by 3?
oh, wait. Never mind. Sorry, pi by 6. And then it would be t minus um, t minus 3
Perfect.
plus 8.
Plus 8. So if we did use a cosine function, it'd be d of t equals 6 cos. Oh, no, that's wrong. I'm just going to fix that. Pi by 6 t minus 3, because the peak is 3 over, plus 8. So they look identical, except in this case, just the phase shift is different. Part C. That was part B. Let's do part C. Yes?
How do you know that the C is equals to 8?
We know the low point is 2, and we know this goes up 6 and down 6, up 6. So we have to add 6. So there's our equilibrium line, add 6. Okay. Was there anything else? Part C. Now, what if the water is at average sea level at 2? How would that change our sine equation? Average sea level at 2. How would that change our sine equation? Any ideas? If all of a sudden that average was moved to there and it started there instead of there, what would happen? Yep.
We'd have to put in pi by 6, then in brackets 2 times 2.
Perfect. Good. Can I explain anything any better? Yes.
I still don't really understand how we got pi over 6.
Oh, the formula is this: period equals 2 pi by k. So we use this to calculate k, right? They tell us one cycle is completed every 12 hours, so the period is 12. So for period, I sub in 12, and then I solve for k. Is it this that was throwing you off, or?
Like, so you just add the pi in the formula,
Yeah.
like 2 pi over 4, because it's your sine function. No, I'm saying about the points. Oh.
So your period equals 2 pi over k, multiply both sides by k, and then solve for k. So you get 2 pi over 12, and that equals pi over 6.
Okay.
So in application questions, instead of just an easy number, you have a pi in that. Ready? Yeah.
But it still shows how the depth changes over the next 24 hours. So should we add a limiter to like is greater than equal to the smaller
It,
times
so you're asking me,
because I said over the next 24 hours, so it should be from 2 to 24.
this will show from 0 to, it shows from 0 to a billion hours.
I know, but the question said how the depth changes over the next 24 hours.
It's this. Huh?
Okay, the question,
If the water is at average sea level at 2 and the tide is coming in, so there's a phase shift of 2 over.
read the whole question.
Okay, write an equation for the graph that shows how the depth changes over the next 24 hours. That covers, that 24 hours is covered here.
How is that 24 hours the same?
Because you can plug in t equals 24. You can plug in t equals 50 if you wanted to. Okay? So it's okay, it's covered. I don't know, they could have just said, we could have thrown that out and got the same answer.
It's confusing.
Yeah, I hear you. I understand why that would be. Okay. An object suspended from a spring. Okay, so there's this object. It's suspended from a spring. And you pull it down and it bounces up and down, right? Do, 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 do. So the height follows that sine function or a cosine function. The distance from the high point to the low point is 30 centimeters. What does that tell us about A? What is A? No. The low to high is 30. This is 30. So what is A? 15. A equals 15. Okay? And the object takes 4 seconds to complete 5 cycles. So you have 5 cycles. We're doing some rough work here. 5 cycles in 4 seconds. So that means 1 cycle in 4 over 5 seconds, and that's just equal to 0.8 of a second. So our period is 0.8 of a second, right? A is 15, period is 0.8 of a second. Special points are what? Period divided by 4, right? Yeah. I'm sorry, Michael, did you have a question? I just remember you raising your hand before.
Oh yeah, that was. How do you know the? So that was for the example one. If you know that there's a period, how do you know the period number?
Oh, they tell you one cycle is completed every 12 hours, so one cycle takes 12 hours, or the period is 12 hours.
So period always equals the cycle.
Yeah. The length of a cycle is 12 hours. That's your period. The length of a cycle.
Does that like apply for all application questions?
Yeah. So the length of that cycle is 12 hours. There's a complete cycle. It's 12 hours. I forgot. I remembered you had your hand up. Okay. Let's maybe start drawing it, okay? So here we don't know where the floor is in this question. That's a big question mark. So we're not going to worry about it. We'll just draw the equilibrium line. And we're doing the height, I guess. Oh, they're using a distance from the mean position, so we'll call it t. So we'll say it's going above the mean distance or below the mean distance. Above the mean distance or below. So the mean distance would be the resting point. Okay. So this would be 0. So we know our amplitude is 15, so it's going up to 15 and down to minus 15. So 15 above the mean distance or 15 below? Yes.
How come the zero's behind the axis, the vertical axis?
We're just saying the mean distance is at 0. So this is our y-axis. So that's in centimeters. Okay? So sketch a graph for 2 cycles. So we need 1, 2, 3, 4. 1, 2, 3, 4. I feel like I'm doing exercises. And this will be time in seconds. Okay, so special points occur every 0.2 second. 0.2, 0.4, 0.6, 0.8, 1.0, yeah?
What's that point?
Huh?
Wait, you see the point?
What?
No, no, no. The other one.
This?
After.
This?
No, 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 no. The other side. Other side.
Huh?
Zero.
This? Oh, that's
What's
0.
that? Okay,
Yeah.
thank you.
We're just treating the mean distance as 0. Oh, does it? Okay. It wasn't my intention to make it look like that. 1.2, 1.4, 1.6. Okay, so it says here, the spring oscillates up and down, a distance from high point, okay, they told us that. For the first few cycles, the distance from the mean position. So it looks like they want us to start at the mean position and modeled by a sine function. So this will go here, up, down, down, up, up, down, down, up. So that's our A. Write the equation that describes the distance of the object from its mean position as a function of time. Okay. So we got y equals a sine k, t minus d plus c. We know what a is, so but instead of y, we're going to use distance as a function of time. Our a is 15. We have to I don't think we calculated k yet. I shouldn't have wrote k. So let's you know period equals 2 pi over k. Our period is 0.8, and that equals 2 pi over k. 0.8k equals 2 pi, so k equals 2 pi over 0.8. You shouldn't really express a fraction with the decimal in it, so multiply it by 10 to get rid of the decimal. So that's 20 pi over 8. That's 20 pi over 8. And that's equivalent to 5 pi by 4. Yes?
Why didn't we use, instead of point A, why didn't we use 4 or 5?
Oh, that would have been easier.
Yeah, but not
It's
quite.
5 pi by 2. Yeah, that you could have done that, absolutely. Absolutely. Okay, so that would have been easier. Thank you. I'll try to remember that in the future. 5 pi by 2. T. Is there a phase shift?
No.
No. What's C? 0. So we don't have to worry about that. So I have a challenging question for you. Okay, I'm going to make up a question. At what time, why don't we put in times, is the distance 7.5 meters above the mean position? Now they're telling us the distance, but boy, we have to now calculate the time. Look at where our t variable is. So where do we start? Any idea? Yeah?
You said 7.5 meters into the D bracket.
Yeah, so this is 7.5 equals 15 sine of 5 pi by 2t. So 7.5 divided by 15 is 1/2. So when does sine equal a half? Yeah.
Oh my god.
Yeah, we got to bring out this stuff. So sine of 30 equals 1/2, but we're working with radians. So we have to write what? Sine of pi by 6 equals sine of 5 pi by 2t. So if sine of this equals sine of this, then we know pi by 6 equals 5 pi by 2t. Right? Multiply both sides by 12.
By 12.
Yeah, to get rid of the denominator.
So you mean 6 times 2 equals 12.
Yeah.
Okay.
So this is 2 pi equals 30 pi by times t, right? 2 goes into that once, 2 goes into that 6. That's once, that's twice. So t equals 2 pi over 30 pi, and that equals 1 over 15 seconds. So at 1/15 of a second, the height is, uh-oh,
Why didn't you say times?
yeah, should we calculate more?
No, I don't want to, but
Okay. All right. Do you see the 7.5 occurs here, 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 and here? Agreed? So, what are other times it's 7.5? We got 1 over 15 seconds. How could we calculate this guy? That would be zero point 0.4, yes, 0.4 minus 1 over 15. What would this guy be? Well, it's going to be 1 over 15 plus zero point 0.8 of a second, because that is the period, right? So that's a complete cycle. We add the period. And this guy would be 1.2 minus 1 over 15, right? Because it's symmetric. If this is 1 over 15 above that point, this one's going to be zero point 0.4 minus 1 over 15. And this one's going to be 1 over 15 plus zero point 0.8, or zero point 0.8 plus 1 over 15. This is going to be 1.2 minus 1 over. So there's 3 times. If you had a calculator, you could. Good? One more example, I think. Yes, we have to do one more example. A Ferris wheel question. Ferris wheel. Do you guys know what a Ferris wheel is? You sit on it, and you have a good time, and all the people are riding, and they're all going, ooh, 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 it's so scary. They're telling you the amplitude is 7 meters, right? It's a radius of 7, which is equivalent to A. The period that's our period, 16, right? One complete revolution is 1 cycle, or 1 period. This is our minimum point, min. Draw a graph to show up how a person's height above the ground varies with time for 3 revolutions, starting when the person gets on at 1.5. Okay, so let's draw it. Okay. Okay, the bottom of the Ferris wheel is 1.5. The radius is 7, so this is going to be 8.5. And we add 7, and that's 15.5. Yes, I'm very sorry. Okay, so we're doing height with respect to time, and we're doing it in meters. They want 3 cycles, so it's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And this is time in seconds. So the period is 16 seconds, and you know special points occur every period divided by 4, every 4 seconds. So this is going to be 4, 8, 12, 16, 20, 24, 28, 32. That's 2 cycles. 3, 6, 40, 44, 48 for 3 cycles. Now they tell you the person gets on at the low point. Let's just do some. Can I answer any questions? Yes.
How do you know that there are 4 points in a cycle?
Cycle has 5 points, so it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
How do you know that's 5?
Remember from the very first day, from the very first day, a sine function had 5 key points. Remember, 0, 0, pi, right, 1, 2, you're relating it to that, yeah? Okay, he gets on at the low point. So he starts here. There's 3 cycles, yeah? Oh boy, find an equation for the graph. Okay. Well, we could do sine function, we could do cosine. Let's do a couple of equations. So, you know period, I'm just calculating k, equals 2 pi over k. So our period is 16 equals 2 pi over k. 16k equals 2 pi. K equals 2 pi by 16, and that's pi by 8. So let's do it. H of t equals what? What's our amplitude? What's this? 7 sine. Our k is pi by 8. T, what's the phase shift? Phase shift is 4 to the right, so we write minus 4. And our equilibrium line is y equals 8.5, so it's plus 8.5. Yes? See how sine usually starts here and goes up, but it's starting there, 4 over? So there's a phase shift of 4 to the right. Yes? We'll do a cosine. We can use either one. Here I assumed it's sine. Let's do a cos equation. What would be the simplest cos equation? Negative 7 cos pi by 8. Is there a phase shift if we just put negative 7 cos? No. Normally cos starts here, but now it's starting here. There's an infinite number of equations for sine functions. The test question will ask you for the smallest phase shift. So in this case, the smallest phase shift is 0, so that would be your best answer if they ask for cosine. Mike, is that okay, Michael? Okay. Yeah, they did. They just said write an equation for the graph. They're both good. Predict how the graph will change if the Ferris wheel turns more slowly. What would happen? If the Ferris wheel turned more slowly, how would the length of our cycle change? Wider, yeah. So our cycle would take longer. And you're absolutely right, there is a horizontal stretch. So D is basically repeating the same thing but with 20 seconds. So I'm going to let you, would you like me to do that or would you like to try it on your own? Huh? I can do it. So we're just changing it's just a horizontal stretch, so everything stays the same. This is, he gets on at 1.5. The Ferris wheel, the radius is the same. I'm sorry. So this is 1.5 plus 7 is 8.5 plus 7 is 15.5. He's getting on at the lowest point. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is time in seconds. We have to calculate our special points is equal to 20 over 4, and that equals 5. So this is going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Just draw some grid lines. Starts at the low point. There's our graph. We have to calculate K, right, to get our equation. So period equals 2 pi over K. K equals 2 pi over 20. That's pi by 10. So our equation becomes h of t, 7 is the same, sine pi by 10. Now we have a phase shift of 5 to the right, plus 8.5. I did that kind of quickly. Does anyone have any questions or anything I can explain better? Yes? Oh, you're stretching. Anything I can do for you? Guys, try number 4. You guys do number 4, and I'm going to walk around and help